And good afternoon. So we'll go with another topic for heat transfer, convection. Very short lang naman at sinamarize ko na yung kanyang gagamiting mga formula and equation. So what is convection? Kung ang conduction is a transfer of heat from a single body, a hot body to another side, okay? From hot side to a cold body. So convection is a mechanism of heat transfer whereby heat energy is transferred by moving fluids. So meron kang heat exchange between moving fluids. And the most important dimensionless group in the analysis of heat convection are this is affected by number 1, yung Reynolds number. Ginagamit po natin yan sa flow in order for you to determine in what flow ang pinag-uusapan natin. Si Reynolds number, sir, yan po, nadidetermine natin if the flow is, pangit na kulay. So, you will determine if the flow is laminar or turbulent. Ginagamit po yan. And the Prandtl number, to commonly, hindi na masyadong ginagamit sa ating mga board exam. The Nusselt number and the Grashof number. They are dimensionless coefficients na ginagamit natin for convective heat transfer. Now, we have two working equation here. Now, there is a convective heat transfer with known specific heat nung fluids. Okay? That is in contact with. Magkakaroon silang thermal equilibrium. Kumari, hinalo mo or magkakaroon sila ng heat exchange. So, yung tubig mo, it came in contact with cold air. So, sa system na kung saan nag-introduce ka ng cold air at meron nagpa-pass through na tubig, mainit na tubig, magkakaroon sila ng heat exchange kung saan magkakaroon sila ng meet-up point na equal yung kanilang heat. Okay? At different temperature changes, okay, one of them will gain a temperature rise and then one of them will lose a temperature quantity. Okay? Bababa yung kanyang temperature quantity. But, i-determine mo doon yung pwedeng yung kanilang separate masses. Well, technically, magkaibang mass or magkaibang quantity ng mass, magkaiba ng specific heat, madidetermine mo yung magiging change in temperature nila. But, the heat transfer is always constant or the heat quantity is always constant. Now, for surface convection, ibig sabihin, hindi to convection, convection. Okay? For surface convection, this is the convective heat transfer that is given by the formula Q is equal to HA delta T. Napag-usapan na rin natin yan dun sa overall conductance, the general formula for heat transfer or conduction, where H is the convective heat film coefficient. Yung H, anong unit niyan? That is watt per meter square degree Kelvin or BTU per hour feet square degree the degree Rankine or degree Fahrenheit. Okay? Ito yung sa surface convection. Now, let's get back with convective heat transfer with known specific heat. So, dapat alam mo yung specific heat of the material that has been undergoing convective heat transfer. Number 1, ano mga common dyan? The constants. The constants there are for air, for water. Sir, sa water, the same lang yung kanyang specific heat at constant volume and specific heat at constant pressure. Parehong 4.18. Now, yung heat transfer mo, heat transfer of may kakaroon ka ng phase change. Pwede rin po yan. Okay, yung sa water into ice, ice into water. Kailangan alam mo din yung heats of fusion of water at heats of vaporization ng water. Sir, ano po ba yung heats of fusion of water? Heats of fusion. Ibig sabihin, it is the amount of energy you need to turn a kilogram of water, heat of fusion. It is the quantity or the amount of energy you need in order for you to turn a kilogram of water into ice. So, heat of fusion na. Kapag HV, heat of vaporization. Actually, ito, latent heat of fusion, LHF. LHV, latent heat of vaporization. Okay. It is the amount of energy you need to turn a kilogram of water into vapor at 100 degrees Celsius. Okay? Alitin ko, latent heat of fusion. It is the amount of energy you need to turn 1 kilogram of water into ice at 0 degrees Celsius. Yun yung buo. And latent heat of vaporization is the amount of energy you need to turn a kilogram of water into vapor at 0 degrees Celsius. So ano po ba yung mga values niyan? LHF. This is 335 kilojoules in every kilogram. So you need 335 kilojoules in every kilogram of water to turn it into ice. Convert nyo na lang BTU per pound. Kaya na yun. So LHV is 2,500 ata. 2,500 kilojoules in every kilogram. Kung natatandaan ko pa, to turn water into ice. To turn water into kung hindi ako nagkakamali, 2442 ata. Check na lang natin dito sa heat transfer natin. Yung latent heat of fusion, nandito yun, nailagay ko. Yung sa constants. Ito yung sa Reynolds number. Okay, maya puntahan natin yan. Ito, mga... Yan, latent heat of vaporization for water. Ginagawa ko lang 2.5 yan. Latent heat of vaporization for water, that is 2442. LHV is 2442. 2442 kilojoules in every kilogram. Ang latent heat of fusion is 335 kilojoules in every kilogram. Yan. Yan na yan. L335 or 334. Latent heat of vaporization for air pala to, air. Okay? Huwag natin isama. Okay. Pag-uwi natin. Tama pala yung ginagawa ko kanina. 25. Saan yun? Ayun. 2257. Hindi ko natanda. Naghahalo-halo na sa akin. So, 2257. 335 or 334, okay na yun. Kilojoule per kilogram. Okay? I'll correct myself hindi 2442 kasi that is for air. Air. Yan, nakalagay nga sa taas air. So, CP of water, ito yan, diniscuss ko na sa iyo. The CP of water is twice nung sa ice or CP ng ice is half of water. Binaliktad ko lang. Dito, kapag English units naman, the latent heat of fusion, you need 144 BTUs of energy in order to turn 1 pound of water into ice at negative, kapag SI, 0 degrees Celsius ang freezing ng water. Kapag naman English units, that is 32 degrees Fahrenheit. Ngayon naman, 970 BTU per pound mass, you have 970 BTUs of energy in order for you to turn 1 pound of water into vapor at 100 degrees Celsius yung boiling point ng water sa SI. This is 212 degrees Fahrenheit kapag sinabing English units. Okay? Yun. Now, let's go with yung sinasabi kong convection. Okay, if the convective heat transfer, convective surface heat transfer is given by this formula. Q is equal to HA delta T, where A is the cross-sectional area of heat transfer and H is the surface film conductance of the fluid that is in contact with the material na magkakaroon sila ng heat transfer. Now, let us go with the non-dimensional or unitless numbers. Reynolds number, okay? Yung Reynolds number, it is given by VdP over mu d. Okay. Anong tawag dito? Okay? Yung nasa ilalim is the viscosity of the material. Viscosity. Okay? Kapag mu d, nakalagay mu and d, this is dynamic. Kapag mu and k, this is kinematic. One is moving, one is stationary. Okay. Ito is volume, tapos ito diameter nung hindi ako nagkamali, volume, diameter. Tapos yung rho dito is the density of the fluid. Okay? Unitless po ito. Non-unit. The Prandtl number, if the Reynolds number is inertial and gamit mo is a viscous fluid, a Prandtl number, it is the momentum na meron ka dyan divided by the heat. Okay? Constant itong K. Yung Cp din, specific heat ng material mo. The Nusselt number, yung temperature gradient divided by the overall change in temperature, Hd. And then Grashof number, the buoyant force divided by the viscosity. Ito. The beta gravity delta T. D, ito, tama ba diameter? O, diameter ata yan, malaking D. And then, density pa rin yung rho squared, yung beta, gravity, and delta T, mu D. Okay? Let's go with convective heat transfer dito. Nandito ba yung convective heat transfer? Well, actually, parang natapos ko na dito sa taas. Na-discuss ko na yung convective heat transfer. Ayan, nandito. Convection. So, what better way for us to understand it is to simply apply it with different problems. So, I have 5 problems na na-discuss na. All you have to do is have a follow-up on them. And then, I'll give you the notes if you need it. And then, ngayong araw na to, we'll have to solve 4 problems para sa ating convection. So, let us go with the solving of the problem. So, I have here 4 problems. Tapusin natin sila sa isang pasada. So, this is problem number 1. So, problem number 1, sabi dyan, a heat exchanger has an overall coefficient of heat transfer. So, overall coefficient of heat transfer coming from this one, Q is equal to UA delta T. Where U is the overall convective coefficient of heat transfer. So, UA delta T, di ba ang U is simply the reciprocal ng RT or the overall resistance of the material or of the heat transfer. Okay? So, ito po yung binigay niya. That is 900 watt per meter square degree Kelvin. Okay. The mean temperature difference, ibig sabihin, this is pwede ring maging delta niya. Or delta niya mismo yan. 200 or 20 degree Kelvin yung naging difference. And the heat lost, the energy that is lost, or heat energy that is lost is 15,000 watts. What is asked? Calculate the heat transfer in area. The heat transfer area in square inches. So, may problema ba tayo dito? Lahat naka-SI? All we have to do is to convert it after natin makalculate yung buong value. Now, if this is the working formula, Q is equal to UA delta T. U is given. Delta T is given. The heat transferred is given. All we have to solve is the area of the heat transfer. So, i-reform natin yung equation natin. Okay? In favor of A, para yun lang naman ang isi-solve natin. So, Q is equal to, A is equal to Q over U delta T. O, given naman si Q, that is 15,000 watts. Si U is 900 watt per meter squared degree Kelvin. And then the change in temperature is given there, which is 20 degree Kelvin. But we are asked to find the value. Okay? Yakit na lang natin to dito. So we cancel all the same units, yung watt, watt, degree Kelvin, degree Kelvin. So aakyat dito si meter squared. Tanggalin ko na to dito. Meter squared. Ngayon, saan po muna tayo dadaan? Okay? I want to simplify this by doing this conversion. Dadaan tayo ng feet. Okay? You have 300 tuloy, sorry, 3.28 feet in every meter. Kaya lang, naka-square yung meter mo dito, di-square din natin to yung value niya. And then, in order for you to get the desired unit, hanapin mo yung conversion factor nung sa feet. If you have feet squared there, feet squared is equal to, ilan? 144 inches squared. Lagi niyong tatandaan to. Nagagamit din po ito saan? Nagagamit po itong conversion na ito sa fluid mechanics and fluid machinery. Diba yung pound per inch squared? Diba lagi merong ganon? Minsan may times na kailangan mong gawing i-feet squared yun. Pound per feet cube. Minsan binibigay sa specific weight of the material or the fluid. Okay? So, tandaan niyo yung key conversion. Key conversion, 144 inch squared is equal to 1 feet squared. Huwag natin kakalimutan to. Meron pa po tayong hindi dapat kalimutan dyan. Key conversion again. Mamaya, lagay ko muna to. Answer natin. We cancel all the same units. Yung m squared. Okay, yung feet squared. Ang natira is inch squared. The value now is 15,000 multiplied to 144 times 3.28 squared divided by 900 times 20. The value for your area is in inches squared 1, 2. Okay. Area is equal to 1291.008 inch squared. That is the surface area of heat transfer. Now, marami pa tayong dyan. Marami pa tayong conversion unit. So, dadating tayo sa convection, di ba? Convert natin to. You have 1, yung conversion ng gallon. You have 7.481 gallons. Equal yan sa 1 cubic feet. Okay? You have 3.785 liter in 1 gallon. Meron pa. Ano pa yan? You have 1 kilogram. Ito, water lang to is equal to 1 liter ng water. Sa water lang to applicable to. So, ibig sabihin, the density of water is equal to 1 kilogram in every liter. Sa mass, meron pa. You have 2,000 pounds equal to 980 kilograms. Pwede na tong conversion na to. Tapos, 1 pound, 7,000 grains. Huwag niyong kalimutan to, mga conversion factors na yan. Okay? Tandaan na ba yan? Let us proceed. Next problem. The mass flow rate of Freon refrigerant. Okay? Sir, refrigeration na yan. Heat exchange pa rin naman yan Through a heat exchanger is 10 kg per meter. A minute per meter. So, the mass flow of the refrigerant is equal to 10 kilogram per minute. The enthalpy of the entry freon is 245 kilojoule per kilogram. So, H1 ng entry, 245 kilogram, kilojoule yan, kilojoule per kilogram. The exit now is H2, 55 kilojoules in every kilogram. Water coolant is allowed to use 10 degrees Celsius. Determine the water flow rate. Para ito yung refrigeration chamber mo. Okay? Ito yung entry ng iyong refrigerant, okay, MREF. Lalabas siya dito as H2. MREF pa rin yan. So, yung nag-give off siya ng heat, okay? It gives off heat. Okay? Q. Ngayon, meron ka diyang cooling water. This is the cooling water. Okay? Meron kang in, out. Siyempre, yung heat na ito will be equal dun sa heat na i-absorb ng water. Ibig sabihin, the heat that is given off by your refrigerant is equal to the heat that is absorbed by water. Ngayon, meron tong delta T na 10 degrees Celsius. Paano natin nahanapin yan? By equation, okay, we can say that the heat transferred from the refrigerant is equal to the heat that is absorbed by your water. Sir, alam po ba natin yung CP ng refrigerant? Hindi natin alam. Okay? Pero, di ba sir, binigay yung mga enthalpies. Tama. If that is constant pressure, heat addition, ano po ba yung kanilang heat added? That is given by the formula. Heat transfer, ibig sabihin, this is a process of constant pressure or isobaric. Okay? Ibig sabihin, kapag isobaric yan, note natin. Okay, note. Kapag isobaric, Q is equal to M delta H, where M is the mass flow rate of your fluid and delta H is the change in specific enthalpy of the inlet and outlet measurements. So, dito pupunta yan. Okay? Pwede natin i-reform. The heat that is absorbed by your water is convective. Okay? Convective yan at constant pressure. So, M Cp delta T. And your refrigerant, that is M delta H. Okay? Now, mahahanap ba natin yung mass ng water? Yes. Lagay muna natin dito. Q ni water is equal to Q ng refrigerant. Now, M ng water is equal to, multiplied to the specific heat at constant pressure ng water, delta T, dun sa water lang, equal to, yung Q ng rep, M rep, H1 minus H2. Entry and exit or whichever is higher. So, ang hinahanap natin dito is the mass flow rate of water. Water flow rate, okay? Mass flow rate ang binigay dyan. So, M ng water equal to, ilipat na natin to dito, M rep, H1 minus H2, okay, Cp, water, tapos yung delta T, water. Sir, may encounter pa ba namin to into the later parts? Yes, may encounter nyo to saan? Number 1, sa power plant, refrigeration, kung tapos na kayo, at yung air conditioning, pag pumunta na kayo ng cooling tower. Tatlo ang heat exchange dyan. Number 1, sa system mo, ang nagpapalamig ng iyong air conditioning, magkakaroon ka ng heat exchange dyan. Okay? Nagpapalamig dyan is the refrigeration system. Yung refrigeration system mo, gagamit yan ng water from the condenser. Yung condenser mo, tatanggalin yung heat ng iyong refrigerant. Doon, sa heat ng refrigerant, mag-give off siya ng heat exchange. Okay? Anong gagamitin? Commonly, kapag cooling tower, that is water. Pagdating ng cooling tower mo, meron kang inlet and outlet temperatures ng water, kung saan yung ibinibigay ng iyong refrigeration system is mainit. Iinit yung tubig, papasok sa cooling tower mo, lalabas sa cooling tower mo, malamig na. Sir, anong medium naman yung ginamit mo sa cooling tower para palamigin siya? Actually, ang cooling tower, either passive or pwedeng forced drop. Forced drop tsaka induced draft. Okay? Or passive, pwede rin, hangin lang. Ibig sabihin, hangin ang ginagamit nila. You introduce air or you suck air para magkaroon ng heat exchange sa water mo. That is evaporative cooling. Okay? Yung cooling effect na yon, kukunin ng air dun sa tubig yung init. Okay? Droplets of air. Ngayon, itatapon siya outside. Sabihin, nakadepende pa rin yung paglamig ng tubig mo na coming from your condenser dun sa lamig ng ambient air mo. Kasi saan ba galing yung air mo? Sa surroundings. Kaya most of the time, you can see yung mga cooling towers, yung may ingay na nasa taas ng mga building, nandun sila sa top floor. Ganun po ang ginagawa. Kasi it saves energy by utilizing the ambient air na dumadaan doon sa taas ng inyong gusali. Okay? So let us get back here. Meron na tayong working equation. Okay. Meron tayong MREF, meron tayong H1, H2, CP ng water, that is constant, and then delta T given naman. We can now solve for the value of the mass flow ng water. So you are given there yung MREF, that is 10 kg in every minute. Yung H1, that is 245 and 55. 245 minus 55 kilojoules in every kilogram. The CP of water, that is 4.186. 4.187, pwede rin. 4.187. Ay, mas gusto ko 4.186. Pwede na yun. Kilojoule per kilogram, degree Kelvin. So, the change in temperature is 20, kung di ako nagkakamali dyan. Ay, 10 pala. 10 degrees Kelvin. 10 degrees Kelvin. We cancel all the same units. Kilojoule per kilogram, Kelvin and Kelvin. So, ang natira is kilogram per minute. This is very basic. Okay? Yung problem na ito, very basic. Paano kung magkakaroon ka ng tatlo? Merong problem na tatlo ang heat exchange mo. 3 beses ka pong magaganitong formula. Convective heat. Okay? Mamaya, dun sa mga videos ko na ginawa, yung 1 to 5, meron dun technique kapag water alone yung ginagamit mo. Isang pasada na yun, makukuha mo na yung volume of water, kaya lang naka-English unit. Or the heat that is transferred by the system. So, let's get back. 10 times 245 minus 55. I think that is 190. 245 minus 55. 90 yan. 4.186 or 187. Kung komportable kayo, 4.187, okay na yun. Sir, 4.187 para tayo pare-parehas. Okay? Huwag na tayo 4.186. Yung iba kasi, meron pang kadugtong. 4.187, pwede na yan. Pero pag i-check nyo, nandito yan, yung value niyan. Okay? Nandito po siya sa heat transfer in. Ayan, 4.186, 4.187, pwede na yun. Karaniwan ang ginagamit dyan, 4.187. Okay? 4.187. Kasi rounded off value na to. Times 10. So, the value for your water is 45.38 kilogram per minute. That is the value of the mass flow rate of water. Next one. A metal rod is 10 centimeters long haba, and has a diameter of 2 cm one end, is in contact with steam at 100 degrees Celsius. Okay, drawing natin. While the other end contacts a block of ice at 0 degrees Celsius. So, ito daw yung iyong metal rod. Yun. Yan yung metal rod mo. Tapos, nandito sa dulo yung block of ice. Okay? Yan yung metal rod mo. Atensya na yung drawing ko, ha? O, ngayon, meron daw ditong steam. Mainit. Mainit yan. Steam. Ito yung rod. Tapos, ito yung ice. Yung steam, that is 100 degrees Celsius. Tapos, yung ice mo, that is 0 degrees Celsius. May mapapansin kayo dyan, di ba, ang heat transfers from one hot body to a cold one. Okay, ibig sabihin, after some time, magta-travel yung heat going to this side. Ibig sabihin, the ice will melt and then magkakaroon sila ng thermal equilibrium. Now, the cylindrical surface of the rod is carefully insulated. So, heat flows only from end to end. Ibig sabihin, insulated well to. Kaya may insulation siya. In a time of 20 minutes, binigyan ka ng time, 20 minutes, 320 grams of ice melts. Ibig sabihin, nag-melt siya ng 320 grams. Okay? What is the thermal conductivity of the metal? Okay. Naging H2O na to. Nag-melt yung ice eh. So, na-measure niyo yun. Ibig sabihin, the convective heat transfer there, yung heat that is absorbed by your rod coming from your steam is transferred, to the ice. Kaya nga nag-melt siya eh. Okay? Now, ano po ba yung naging heat transfer dito? The heat transfer here is simply conduction. Nag-conduct yung heat from hot side to the cold side. Okay? Yung sa rod, that is, ano po ba yung formula kapag heat transfer? Di ba meron kang Jejemon, Catex, di ba? Catex. Delta T. Catex. Ano din dito? Now, nagkaroon ka ng change of phase. There is a change of phase. Bakit nagkaroon ng change? Kasi nga, nag-melt yung ice mo. How much energy you need to apply in order for you to change water into ice? Di ba sinasabi ko yan kanina? The latent heat of fusion. That is 335 or 34 kilojoule in every kilogram of ice. So, ibig sabihin, this is convective heat transfer. M ng ice. May CP pa bang ice? Wala. Binigay naman dyan yung heat of fusion. Latent heat of fusion ng ice. Okay? Yan na po yun. So, anong hinahanap natin dito? Yung thermal conductivity of the metal or the rod. So, K. Meron tayong area, meron tayong delta T, meron tayong X, yung trinavel niya. Yung length na trinavel niya. Okay? Dito yan. Ayun, 10 cm long. And then, yung sa ice. Okay. So, what will be the value? Hanapin natin si K. K is equal to, okay, reform natin. M ng ice multiplied to HF multiplied to X divided by area delta T. Ang problema mo dito is the area of the rod. Okay, the rod is cylindrical. What is the area? Area of the cylinder. Okay, area of cylinder is equal to pi dl. Sir, hindi ko alam yan. Bahala ka sa buhay mo. Okay? Or 2 pi RL. Okay. Di ba, pag hinati mo sa gitna yung rod mo, binalon mong ganun, di ba? Para siya nag-form ng rectangle. Okay, that is the area. Going back to your solid mensuration, kailangan alam mo yung surface area. Okay? Now, what will be the thickness? Ano bang thickness dyan? Ito ang thickness niya. Diameter 2 cm 1 and ayun, yung length na binyahe ng iyong init. Okay? So, K is equal to mass of the ice, that is 320 grams. Nakalagay dyan, 320 grams or 0.320 kilograms in 20 minutes. Okay, yung time. Mass flow rate to eh. Okay, mass flow rate yan. O di yung time, 20 minutes. Kaya lang gagawin ko seconds to. Okay? So, 1 minute every 60 seconds. Multiplied to 335 kilojoule in every kilogram. Multiplied to yung binyahe niya. Ilang centimeter yon? O, 10 cm, ibig sabihin 0.1 meter. Kapag calculable naman mentally, i-calculate mo na. Kaya na yon. And then, 20 minutes, may time. Tapos yung area. Area is may mali ata ako dito. Area lang pala nung rod. Cross-sectional area, hindi pala surface area. The cross-sectional area, pag cylinder, ito yung surface area. Pag naman cross-sectional, yung pala yung tinawid. The cross-section is not this one not this one. The cross-sectional area ng, tignan nyo saan ba nag-pass through yung heat? Dito sa cross-sectional area na bilog. So, that is yung area ng circle. That is equal to pi over 4 d squared. Okay. Ito yung area is pi over 4 d squared. Not this one Purahin na natin para hindi kayo nalilito. Cross-section. Okay. Area is pi over 4 d squared. Yan, na-correct ko na. So, that is area pi over 4. Yung d mo dyan is, hindi ako nagkakamali, 2 cm. Divide mo ng 100. 2 over 100 para maging meters square. Tapos, delta T is 100 minus 0. Sir, saan ang galing yan? Degree Kelvin. Naging from steam na 100 degrees Celsius to 0 degrees Celsius. So the answer is 0.320 20 times 60 multiplied to 335 times 0.1 divided by pi over 4. Uy, mali. Yan. Shift pi over 4. D squared, that is 2 over 100. Square mo. Multiply to 100. So, the answer there will be, tignan nyo yung unit muna. Tignan nyo muna yung unit of cancellation. So, cancel natin si minute. Tapos, kilogram. Yung meter, nasa baba, meter squared. Yan, isa. Hinanap natin. Ano po bang desired unit natin dyan? Take note natin. Yung K natin, ang unit niyan dapat is watt per meter degree Kelvin. Kilojoule per second, that is kilowatt. Lalabas dyan, kilowatt, di ba? Cancellation na tayo dito. So, 1,000 joule is equal to 1 kilojoule. 1 kilojoule. Okay? Tapos, 1 watt per 1 joule in every second. Ano may cancel mo dito? Ito na, yung joule per second, kilojoule per second, kilojoule, joule, joule per second. Okay. Ang natira is watt. Tapos, Kelvin, tanggal na. Ay, hindi pala. Watt per meter degree Kelvin. Ayun, may natirang isang meter dito. Okay? So, multiply na lang natin ito ng 1,000. The answer will be K. 284.3568 watt per meter degree Kelvin. That is thermal conductivity of the metal rod. Last problem. At an average temperature, wait lang. At an average temperature of 100 degrees Celsius, hot air flows through a 2.5 meter long tube with an inside diameter of 50 millimeters. The temperature of the tube is 20 degrees Celsius along its entire length. Convective heat film coefficient is 20.1 watt per meter degree Kelvin. Determine the convective heat transfer from air to the tube. So let us go with the problem. Wait lang. Nag-post yung aking timer. Excuse me. So, anong hinahanap dyan? The convective heat transfer. Q. So, Q is equal to, binigyan ka ng convective heat or convective film coefficient of H, A, delta T. May area bang binigay sa'yo dyan? Siyempre, yung annular area. Annular area. Pag binuyang-yang mo yung tube mo, meron kang tube dyan. Okay, ito yun. Ganon. Ikat mo sa gitna. Okay, ikat mo sa gitna yan. Magkakaroon ka ng area ng cylinder. That is pi dl. Huwag na malilito dyan. Or pi 2 pi rl. Yun. 2 pi rl. Very basic na lang tong problem na to. So, Q is equal to H. The film coefficient, ito yun, H. So, 20.1 watt per meter squared degree Kelvin. Yung A, anong area? That is pi in diameter is 50 mm. So, gawin nating meters. 50 divided by 1,000 para maging meters. And then pi dl, the length is 2.5 meters. In delta T, from 100 degrees Celsius, tapos 20 degrees Celsius. Degree Kelvin na to kasi change in temperature. We now calculate the value of Q. Dapat yan, watt. So, meter squared, cancel natin. Delta K or delta T, yung K makancel. So, ang lumabas na lang is watt. We can now solve for the value of the convective heat transfer, which is 20.1 shift pi times 50 times 2.5 times 80 divided by 1,000. The unit is in watt. 201.5 watt. Kaya lang, ang hinahanap dito, determine the convective heat transfer from air to the tube. Ang gusto niya kasi dito is in HP. Okay? In HP po. Yan. Convert natin ng HP. Ano yung multiply natin para ma-convert natin siya ng HP, yung watt? Simple lang. Multiply mo na lang ng 1 HP in every 746 watts. Ayun, 746 watts. Ayan. Cancel all the same unit, yung watt. Ang natira is HP. Divide natin ng 746. Okay. The answer there will be in watts, in HP. So, Q, or the convective heat transfer is 0.8465, approximately 0.85 HP of heat. Okay, so that is the final problem of the convection. So, yung 5 problems is pre-recorded na. All you have to do is to play them. And I think that will suffice for today. So, if you've got questions, feel free to ask and have a nice day.